Okay, so in this instructional example, we'll let x be the random variable that denotes the number of heads when a coin is flipped 3 times. So if a coin is flipped 3 times, we have 2 times 2 times 2 outcomes. So 2 to the third outcomes that we could list. So that's not very big, it's 8. So let's just go ahead and list them, and we'll use the listing strategy to calculate our probability distribution function. So we could have heads, 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 tails, heads, tails, heads, tails, heads, heads. It's 4 of them. So all heads, 1 tail. So let's take a look at 2 tails. So heads, tails, 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 heads, tails, or let's see, tails, tails, heads. So that's 2 tails, and then I guess the last one would be all tails. So if we're denoting the number of heads, let's take a look at, we'll let x be denoted down here in red. So the number of heads here would be 3, 2, 2, 2, 1, 1, 1, and 0. And so since these, we think of a coin flip as being random, and there's 8 possible outcomes, we can now construct the probability distribution function for our variable x. So if these are the values that x can take on, and in this column we let the probability that those values appear be listed. Then x can take on, well, we take a look here, and we see that x can take on 0, 1, 2, or 3. The probability it takes on 0 is just 1 out of 8 outcomes, so it's 1/8. The probability it takes on 1 happens 3/8 of the time. The probability that it takes on 2, also 3/8 at a time. And the probability it takes on 3 happens 1/8 of the time. So how would we calculate the expected value of this particular random variable? Well, the thing that we are supposed to do with expected value, or that we're instructed to do, is to take the product of the value of the random variable times its probability. So it's just literally the x times the probability that x is equal to x. So 0 times 1/8 is a 0 here. 1 times 3/8 is a 3/8 here. 2 times 3/8 is a 6/8 here. And 3 times 1/8 is a 3/8 here. So these would be all the products of the value times the probability of that value appearing. And the expected value then is calculated by simply summing the columns. So the expected value of x here is going to be equal to the sum of this column. So 6, 7, 8, 9, 10, 11, 12 eighths. And that would be, see, 1 and 4/8, or 1 and a half. One of the things that you should notice is that is exactly in the middle, in a weight sense, in a weighted sense of our probability distribution. You can see the probability distribution is symmetric about this line, and it turns out that line, of course, is the x outcome, which is tied to the expectation, the 1.5 midpoint of our probability distribution. So you can see that the expected value has this placement in the probability distribution that somehow equally weights the outcomes in terms of what value of x would be, in a sense, the center of gravity or center of mass of the probability distribution function. The other way that you can think about it is that if we were to roll in a simulation flip a coin 3 times, we would expect to see these outcomes roughly weighted by these probabilities. So if we summed all the outcomes of, say, 100 simulations of this experiment, and then divided by the number of simulations, we would expect the average outcome to be 1.5.